same stuff that's on the retake. All you got to do is pay attention. And what does that word mean? Yeah, I know what it says, or, but what does it mean? If I say tomorrow morning when I wake up, I will wear a red or a blue shirt. What does that mean? Huh? Well, it could be either one. That there is more than one way to satisfy what is being asked of you. So the other thing to pick up on, it's a little harder because it's fancy words, but okay. When you see relative frequency, what you don't see there is the word conditional. Conditional is when you're limiting. They say conditional relative frequency. That's when you're limiting your sample. But in this case, our sample is going to be the entirety. Does anybody either on the work or does anybody remember what all those add up to from yesterday? Yeah, they add up to 100, right? So it's going to be out of 100. But then when I say tennis, soccer, or both, it could be any of those. How many people like only tennis? Tennis, yes. Soccer, no, would be 18. How many people like only soccer? 48. How many like both? 12. So that's what would go on top of it, because any of those would satisfy. What is 48 plus 12 plus 18? That's 78 over 100. Oh, you're confusing. Even if you didn't understand it yesterday, you understand it. You understand what or? Yeah, that it could be any of them. It could be any of them. How many? No, probability. I know that we didn't have a full lesson on probability, but when you do these percentages, it's a desired amount, a desired frequency over a total. In this case, we're not limiting our total to anything specifically. It's not conditional, so it's over the whole 100. But which one of these numbers satisfies these what's being set up there? Any of those three numbers, because it's tennis, soccer, or both. It could be any of them. So all of those people qualify. The only ones that don't qualify are the ones that don't like anything, because they only like math. Any questions there? All right, the next one. Select the box plot that represents the given test scores. Okay. And these are the ones that were missed the most. I'm not just randomly going over problems. So I'm doing not only 22 out of 30, but the 22 hardest ones. I picked anything that was less than 70%. Anything I don't go over, at least 70% of you got correct. Hi, Antoine. So for a box plot, you want these to be in order. Luckily, this appears to already be in order. How many elements are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. Are you guys counting 16 also? So what's the median for 16? If you have 16 or something. The 8th and 9th, good. 3, 4, 5, 6, 7, 8. I noticed a lot of people made this mistake on the quiz that we took before also. When you have an even amount, you have to take the two in the middle and average them. What is the average of 77 and 78? 77.5. If you are not sure, add them and divide by 2. If you're not sure what's in the middle, add and divide by 2. So we're looking for the middle of the box to be at 77.5. Okay. Then when it comes time to find your quartiles, you would leave everything in. You don't bring anything out. And since half of 16 is 8, there's 8 on each side, but 8 also happens to be an even number. So what numbers are in the middle of 8? Like what would be the median of 4 and 5? Yeah, and then on the other end, what, 12 and 13, I think? But just look at the 4th and 5th number on each side. So 64 and 68, and then on this other side, it'd be 82 and 86. So on this end, if you're not sure, add them up and divide by 2, but I know that would give me 66. I know this would give me 84. So as far as the box goes, I'm looking for the left edge of a box at 66, the right edge at 84, and the median at 77.5. Well, A looks to be at 65 and 85 for my quartile, so it doesn't look like it could be A. Same thing for C. C looks to be at 65 and 85, so it doesn't look like it can be that. So I'm down to C and D. So for let's go with C, I guess. C looks like they're counting by 5. That looks a little further, maybe. That looks like that might be closer to 67, but okay, fine. It's more or less, it's at least in between 65 and 70, so I can go with it for the left edge. This other edge looks like it could be at 84. This could be at 77.5. So I'm not too thrilled about this first quartile, but that could just be the accuracy of the drawing. I'm not ready to exclude it yet. Let's look at the other one. Now, this one does look closer to 66 because it's just inside the 65. That one looks a little more accurate. So does the 84. Oh, but no. Yeah, the median's no good. No good. That's clearly in between the wrong one. So, like, to me, that's enough to exclude it. But just to make sure there's no mistake, let's check everything else. The minimum. The minimum is 48. 48 is in between 45 and 50. Okay, that's pretty good. We could check for outliers, but since this is multiple choice, it's got to be one of the other ones. So like they decided to extend the whisker all the way out there. I'm guessing it's not an outlier. And then on this other end, 91. 91 is just outside of 90. Yeah. So even though it's not perfect because of that quartile, it's close enough compared to all the other ones. It's the one that's the closest. Thank you. Any questions there? Did I go too fast? Sam, I am. Read. You look confused. This is the one where the mistake occurred. So what I had to do as far as grading is I went back and I excluded it from the grading. I just didn't count it. Unfortunately, some people, because it's 4, so it's just A, B, C, D. Some people happen to stumble upon the right answer, but I just didn't count it for anybody. The issue was, I believe, that number there doesn't show up anywhere. So based on trying to kind of use context, what I believe occurred was that number, it came out as 18 for whoever printed this, but it really should have been 8. So I went back and I edited it myself. On the retake, this will show up again, but on the retake, it's corrected. So on the retake, it'll show up as 8. I'm going to treat it on this review as it should with an 8. And then we can find the right answer. So they're going in intervals of 2. So if you think of this as being a number line here horizontally, all right, the first bar, it starts at 5 and it stops at 7. We assume that this is anything that's 5 or 6. This is anything that's 7 or 8. This is anything that's 9 or 10. This is 11 or 12, 13, and 14. And then, there's nothing here that's 15 or above. So I guess I would kind of do the same method where I would try to kind of exclude things. Let's see. Let's start off with the low end. Okay. How many 5s and 6s are there? Let's see. I see a 6. I do not see any other 5s or 6s. So how many 5s and 6s are there? Just 1. So I know it can't be that one. But that one has, huh? Well, C has 2 of them. So we're down already to either A or D. Okay. Now let's see 7s and 8s. 1, 2, 3, 4, 5. That's the one that should have been 6, 7. I'm counting 7s, and 8s. That clearly can't be A, but just to make sure there's no mistake, it always makes me feel better. So here there was 1. Here there's 7 of those. Let's just keep on checking just to make sure. There should be 3 9s and 10s. 1, 2, 3. So that checks out. For 11 and 13, there's what, 7 of them? Sorry, 11 and 12. For 11 and 12, there should be 7 of them. 1, 2, 3, 4, 5, 6, 7. There are 7 of them. And then finally at the end, there should be 2 13s and 14s, which there are. That accounts for everything. So the answer there should have been. I did not count this for or against anyone. I just kind of excluded it from grading. That's why what you see on the grade book today is not up to date, but it's up to date on my grade book. It's just you won't see it until tomorrow. It didn't change anybody's grade drastically. It's just one question out of 30. Caleb, any questions? Okay, this is a good one here. The median salary. This is important here. Because you could probably get the right answer from just looking at the diagram, but if you look only at the diagram, it can be a little tricky. You can narrow it down to 2 of them for sure, but there's a little bit more guessing involved as opposed to if you see this already here. How would you describe the shape of that distribution? It is skewed, and skewed in what direction? What? To the right. It's skewed right. Some of you before were saying skewed positive. Okay, fine. But yeah, it's skewed to the right. How do you know that? Because that's where the tail is. Okay. Now, what I tried to teach you is between the measures of center, what are the 2 main measures of center that we use? Median and mean. Which one tends to go, which one's always going to, on a skewed distribution, which one's always going to be on the side of the tail? The mean. The mean follows the tail, right? Now, the median is usually where the highest frequency is. So if I can't see this here, if I can't see, like they don't tell me what the median is, I'm assuming the median is somewhere around here. Okay, it's around 75, it looks like. So I know for sure, because they want to know where the mean, which one would be the best approximation for mean. Well, I know it can't be A and B, because that's on the other side. That's on the left side of the median. So I'm down to these 2. But then now, if I read and I see that they actually tell me what the median is, because this is skewed, there's no way that the median is the exact same as the mean. It's skewed. It's not symmetric. So therefore, it cannot be. So what the only one it could be, the best approximation. You okay in the car? Take your shoes off. Your shoes hurt? You should go return them or something. New or something? Just wear them for the ladies? Wear them for like the ladies to show off and stuff? Shoes need to be comfortable, man. Okay, a radio station did a survey, blah, blah, blah. What percentage of college students prefer classic rock? And what percentage of college students? So right there, what we're doing is that's a qualifying statement. That's a conditional statement. We are now limiting ourselves only to college students. So my sample is going to be only that group of kids. How many total are there? That's 50, no, 40? No, 50. So out of those kids, how many prefer classic rock? Out of just that group. It's not of all students, it was just college students that they were looking at. Read, I see your attention. Do you question? Okay, so this is another two-way table. what percentage of the students, okay, so now we're just looking of the students speak a foreign language that have math greater than, okay. So this is just relative frequency, because what is the percentage of the students? Not of any specific students, but of just students. So we need to figure out a total. If I add up everything, this is 80, this is 65, which would be 145, and then this is 60, and then this is 85. So in total, we have 145 students. And how many of those speak a foreign language and have a math average greater than or equal to 90? So there we would look for the joint, we look for the intersection, and the intersection of those two is the 70. Somebody with a calculator, 70, that looks to be a little bit less than 50, so is it B? It's like B, 0.48. Giving you the answers. So tomorrow, if you want to pick up your password grade. Right, Caleb? What song are you playing now in your head? Mm-hmm. So you're thinking about the ladies? Do you have a stack of love notes again to pass out? No? Based on the linear model, which is the best prediction for the length of a person's foot if his or her forearm length is 21 centimeters? So this is a scatter plot. Okay? If you were to draw a line of best fit, I know this was on a computer, so maybe it's not the easiest thing, but at the same time, this one's not all that close. So a line of best fit would probably look something like that. And if forearm length is 21 centimeters, that would put you right around here. So this is an approximation, okay, which is the best prediction, best being the key word there. Out of all those numbers, the one that it's clearly the closest to is 22. 22 foot length. You okay? Are you trying to guess how long Caleb's foot is? What type of a diagram is this? Yeah, the box plot or a box and whisker plot. So which of these is true? 50% of the scores for Miss Smith's class are between 60 and 80. Here's so 65 and 80. Here's the part of the box 65 and 80. What percentage does that represent? 25, yeah. On a box plot, each whisker is 25% of the data. Each part of the box stands for 25. 25% of the data. So that can't be right. Can't be A. Let's look at B. 50% of the scores for Miss Jones' class are between 80 and 100. So back to Miss, or actually no, not Mrs. Jones, between 80 and 100. Now, what percentage does that appear to be? 75, yeah, that doesn't look right. The median scores for two classes are the same. Oh, no, there's the median, that's clearly not the same. So either D is going to be right or something was really wrong here. And let's see, the interquartile range of the scores for Miss Smith's class is greater than the interquartile range for Miss Jones. All right, where the interquartile range, you could do it like mathematically, but you can also just look at the picture. The interquartile range is the width of the box. Who has a wider box? Smith. So is Mr. Smith's class, does it have a greater, a wider box? Yeah, yes, it does. You happy with your score, Brandon? More or less. We're gonna do the retake. And more or less. Did Caleb invite you to Bryson Park to play? No. What is the relative frequency of students who like tennis? Okay, they're only saying relative frequency. It's not saying conditional relative. So we're leaving this open to all students. This one out of 200 again? Yeah, over 100. So how many of these students like tennis? Well, it doesn't. We don't care about soccer. We're only looking at liking tennis. So what should go on top there? Not 12. Yeah, 12 and 18, which is 30. 30 divided by 100. 30%. Liking tennis. We don't have the totals here, but if we were to add in the margins, this is 60, this is 40, this is 30, this is 70. So how many people like tennis? Yes, 30. 30 like tennis out of 100. 30 over 100. Which statistic would indicate that a linear function would not be a good fit for the data set? We're looking for not be a good fit, where a line would not be a good fit. Would A be a good fit for a line? Yeah, strong and negative. The closer you are to either 1 or -1, that looks like a line. So I know it can't be this one. Would B be a good fit? It would, sure. That'd be a perfect fit. So we can't have that. So we're down to C and D, which neither of these are perfect lines. Okay, but of the two, which one looks less like a line, or which one is less modeled like a line? C, yeah, because C is it's an upside down parabola. Like D is imperfect, but D you could kind of draw a line where you would have the same amount above and below. It wouldn't be very strong, and who knows? It might even be slightly more to the. I'm not even sure if it would be, probably more negative, maybe. But who knows? But the fact is, of the two, the one that's clearly not is that would be quadratic, not linear. A correlation coefficient, okay, that's what we call R, between two variables is 0.9. How would you describe the value? Yeah, obviously 0.9 is positive, so I would hope we can already eliminate these. So is it strong or weak? Well, 0.9 is very, very close to 1, so it would be strong and positive. I don't know how that one was missing. This histogram displays the ages of a company's employees. This was pre-response. The company hires 7 new employees, and those are the ages of the new employees. What should be the height of the bar for the age range 61 to 70 to represent the ages of the new employees? So currently, like before the new hires were hired, there was nobody between 61 and 70 working there. How many people did they hire now that are between 61 and 70? 61, 63, and 70. Just type in 3. We're going to do the retake. Don't put 3 employees, just write 3. That's the only one it'll accept. Just type in 3. What is your interquartile range? We just talked about this before. It's just however wide the box is. It's the absolute value of, you can either do Q1 minus Q3, or you can always just do Q3 minus Q1. It's probably better to do it that way. So Q3 minus Q1. That's going to be 14 minus 9, which gives me 5. Type in 5. I told you that the ones I'm going over were anything that less than 70% of you got right. There's only about maybe 4 of these that were in between that 50 and 70% range. The majority of these, less than half of you got right. A random group of high school students was surveyed, okay, in the freshman group. Okay, so that's a condition. What percentage of students agree that it should be mandatory to participate in a sport? So if I'm only looking at the freshman group has 53, 12, and 7, that's 72 in total. So out of that group, how many agree? 53. This was not free response. This one I had like a set amount of choices underneath. I'll show it to you. See, here we had a set amount of choices. What is 53 divided by 72 if you happen to have a calculator out? 0.7, 0.736. So depending on what I rounded to, about 74%. I might have had it to the next. Any questions? Shobi, you gonna do the retake? This one I like. This one should have been. The scatter plot below shows the two variables, variable A and variable B, and the line of best fit. So they're already telling you that that line is the line of best fit. Is that line positive or negative? So we know that the correlation coefficient can't be any of those because it's a negative correlation. But does that appear to be very strong? The only two left are negative 0.5 and negative 1.0. If it was negative 1.0, every single one of those points would have to be on the line. Or every single one of those points on the line. No way. So the only one it could be is, notice how I said, what is the best estimate? We don't know for sure. We don't have to calculate it. It's the only one it could be. Negative 0.5. Vanessa collected data about how many servings of fruit her classmates eat each week. How many of Vanessa's classmates eat more than 5 servings? So of the number of servings here, which numbers classify as more than 5? What qualifies as more than 5? 6, 7, 8, and 9. How many are there in total in 6, 7, 8, and 9? There's 4, 6 through 7s. There's 3, 8 through 9. Oh, I can't see that. There's 3, 8 through 9 is 4 plus 3 is 7. That's what you would type in the free response box. Okay, so this one here, which elements would be? Let me show you what it looked like. So this is the one that had a select all that apply. So which of these would be outliers if they were to be added to the box plot below? Maybe it's not the best question because yes, if you add several of them, it would also affect the median and stuff. But it was intended to be more if things stay the way like with the way things are right now. Which one of these would be considered outliers, right? Based on the information we have now. Outliers is and what do we have? We have 0 through 4, and then 18 through 25. So the interquartile range. is 14 minus 9. I think we had calculated that before, is 5. Okay, then you multiply that times 1.5. That gives you 7.5. So we want to know then if Q1 is at 9, 9 minus 7.5 is 1.5. On the high end, 14 plus 7.5 is 21.5. So out of all those numbers that you can choose all that apply, how many of those numbers qualify as less than 1.5 or greater than 21.5? Well, you would have picked 0, would have picked 1, and then how high did it go? Did it go up to like 24? 22, 23, 24. I'll tell you right, I have it in front of me. Yeah, went up to 25. So you would pick 25 also. But that only counted as one question. That didn't count as 6 questions. It only. Yes. Yeah, you have to put all 6 of those in order to get it. Bored? A little bit. This two-way frequency table shows the number of students who play sports and how long. Okay. This word, conditional relative frequency. Conditional means we're going to limit our sample. So we're only going to look so we want students that play football given, and I looked at the test already. You're going to see some of these on the test on Wednesday. So given that they practice less than 1 hour each day, I only want to look at students that practice less than 1 hour each day. That we're accepting that we're limiting our sample to only those people. How many are there in total there? How many people? How many? Yeah, 86 practice less than 1 hour. And then how many of those play football? 21. Round your answer to the nearest hundreds. Huh? No, it can't be 0.2 exactly. The nearest hundreds is 2 decimals. 0.24. All right. This scatter plot shows the monthly high temperatures for Austin in Fahrenheit over a 12-month period, which function best models the data from month 1 to month 9. So I'm not looking at any of the points that are to the right of that line. My line of best fit should only go through those points there. You can just try your best to visualize it. Probably be something like that, where you're trying to get as many points above it and below it, be somewhere in that range. So let's see. Clearly, without dispute, I know that there's always going to be a little bit of margin of error when it comes to drawing a line of best fit, unless you use a graphing calculator. Okay, but if you're trying to eyeball it yourself, there's going to be a little bit of play with it. It's not going to be exact. But we can definitely agree what type of a slope is that. Positive. So at the very least, you can narrow your guess to those two. Okay. So now the question then becomes, well, all right, let's look at the y-intercept. Okay, are we crossing the y-axis at 85 or at 90? If it was close, even if it looks closer to one of them, but if it was something where, relatively speaking, you could make the argument for either one, then I would move on to the slope. But 85 is all the way down here. The only way you would get 85 would be like to do this, and now everything's above it. So, to me, the only one that could be here is and where I had it drawn before, yeah, it looked like it was going around 91, but Oh, okay, that seems to be. What y-intercept? You know that's the y-intercept, right? 3. The number that doesn't have the x next to it, that's called the y-intercept. That's where you cross the y-axis. 85 is all the way down here. It can't be 85. Oh. You want to try to calculate slope? We can try to calculate slope. Here. Let's use these points to calculate slope and see what it comes out to. Or I don't know what. I guess we can even use the last one there, 9 comma 110, and then the other one we're gonna use is 398. So 110 minus 98 over 9 minus 3. 12 over 3. No, let's see, now I'm getting a slope that's closer to 3.5. Huh? I'm probably not using good points. Let me see what they put. C. Yeah, so that's the same one I'm saying, C. But I'm probably just not using good points for the slope. I guess according to them, maybe that should be maybe it should be lower than. So divided by 3 is 4, and 4 is closer to 3.5. But I mean, of the two, it's clearly not going anywhere near 85. If it were to be at 85, like I said before, it would be that that's not that's clearly not going to the majority of the points. I don't like line of best fit. Like it's just easier if you have a graphing calculator to do it for you. If you take the retake, just put C. Okay. Um, the stuff tomorrow on scatter plots is not too bad. I already looked at it. It's not too bad. All right. What's the median here? All right. Well, they give you a key on this. What did we call this before when we learned about the type of diagram? You guys remember the name of these? Or no? So, it's a stem and leaf, yeah. And they give you a key which tells you like, this is the same thing as if I were to have them written out, but it's like the numbers are 40, 41, 45, 47. Like it gives you the key. So if you wanted a median, we need to know how many numbers there are. Just count the numbers over here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And the nice thing is that the numbers are in order. So what numbers are in the middle on 22? Is there two? Did I count it right? Did I count it wrong? No, I'm saying like in 22 numbers, the middle numbers would be 11 and 12, right? The 11th and 12th numbers. So the first one there's 9, so this is 10, 11, so I'm getting 64 and 64, so the median should be 64. Type that in. There should be 10 numbers on each side. 4, 4, 2. Yeah. So 64 is the median. What is the range? Okay, how do you calculate range? Max minus min. The max here is 98. The min is 40. So my range is 58. It's actually 58. That's the min. And then finally, Yeah, this is the one that asks you to calculate the mean absolute deviation. So first you have to do is calculate the mean. There's 1, 2, 3, 4, 8, 10. Can somebody add these up really quick, or if you don't have it on the paper already, what do all those add up to? 12, 20, 2, 46, 4, 5. What is it? 162 divided by 10. So the average is 16.2. We want to go one by one and see how far away these are from 16.2, and then take the average of that. So this is going to be 11.2 away. This one's going to be 9.2 away. This one's going to be 8.2 away. This one's going to be 4.2 away. This one's going to be 2.2 away. 1.8, 2.8, 4.8, 8.8, 16.8. And then add all those up and divide by 10 again. If you add all that up, what do you get? What is it? 70. So those add up to 70 divided by 10. So you can type in 7. Mean absolute deviation. You're seeing how far away the numbers in black are from 16. If you want to use the calculator, subtract. Just whenever you get, make sure it's positive. 16.2 minus 5, 16.2 minus 7, 16.2 minus 8. Any questions? Okay, test tomorrow. Caleb says he's going to get 100.